for this
Right,
course.
right. Yeah. Close call.
Yeah, cool. So, I mean, why for now, just all of you go to this link over here. We'll use it in a later point in this session, but just go and download it for your specific system and just keep it ready, okay? So we can directly jump on and start working on it, okay? And there's instructions if you want for Mac and Linux as well. Pretty straightforward. Okay. So basically what Postman is, it's like an API testing tool where you can, whenever you create your backend applications, you need to test them out, right? Your browser is not enough. Basically, every URL that you type over here, it's an GET request to another server. You cannot simulate post, put, delete requests, which we'll see in detail in a while. That they are not possible through your browsers unless you write them in probably in a fetch function inside the console or somewhere. Okay, so but that also is quite limited. You'll lose the history. You'll have trouble debugging in your browsers. That's why we have tools like Postman that make the job easier. So you can keep your things categorized, organized. You can see detailed insights of how your API requests are working. Gives you the response time, like it took this many milliseconds for the data to come. You can automate tests, like maybe suppose if a API call fails to give a specific expected data, then you can say the test failed for this. It's a pretty cool tool overall. Okay, uh, this is like the general workspace organization of how Postman is. So you have a top level workspace. Imagine Think Digital, right? So that is the whole workspace. Then inside that you can have n number of collections. Maybe the first collection is like the Atom project. Second collection is maybe one of our own in-house projects which we like plan with the ML domain, right? That can be one. Then within each project you can have many folders. So folders basically, suppose say I'm working on the login feature. So the login feature can have many endpoints. So for that I can categorize them in one folder. Then maybe the profile for one user, like fetching the profile, editing the profile, all that. I can put those under another folder, keeping things organized. And inside those, finally, I can have my requests. So that can be of many categories: get, post. We have n number of, I mean, not there's a fixed number, obviously, but yeah. So there are methods that you can use to uh, run your API test within the application. Okay, uh, I'll just open up Postman. I mean, it's a pretty cool application, to be honest. Uh, yeah, okay, pretty cool. So I have my account here and I have workspaces here. So I have Think Digital, I have my own projects over here. Okay. So just for example, this is my team workspace. Basically what uh, damn, I got disconnected. Can anybody tell me where I got cut off?
Postman.
Postman, right? Okay.
Right. I think social sphere का कुछ था.
Oh, right. Okay. From here, right? Cool.
Yeah.
So yeah, so I mean, I'll just start from this page. So you have a workspace. In workspace, you can have multiple collection where each collection is basically like a project. And in each collection, you can have many folders that can represent a specific feature. In this case, it's the user or the links. And let's just take a look also. Shameless project plug, but okay. So you can just come here. I'm already logged in. So what I can do is I can add a link. So I can add title, description, link, and all those. And what's basically happening is it's a feature, right? So I'm going to create a link, which is basically a post request that will take these details, which I can type in Postman and send it to the backend without actually writing a function in the code to test it out. It will give me the response, like how much time it took over here, what was the actual response data, all of those included. I guess I'll have to. Okay, no worries. We'll look at it in a development level for now. Okay. So we'll come back to Postman, just not now. So I hope you're familiar with the workspace environment. Okay. I'll show you how to use it also in a while. All right. So let's take a look at the next part. We have package managers. We saw a small overview in the last session, right? We saw npm and how to just use one of the commands, npm install alone, and npm init as well, if I'm not wrong. I guess, yeah. npm init. We saw this one as well to initialize projects. Okay. So some of the popular package managers we have is npm, yarn, pnpm. Okay. PNPM basically stands for performant package manager. Like yarn is better than npm, pnpm is better than yarn. There is slight differences in how each package manager works in installing your dependencies. But we don't have to worry about that at the moment. We'll just work with npm. Okay. All the commands are more or less the same between all the three package managers. So it's not much difficult shifting between one to another. All right. So we saw npm init to create a new project, npm install to just install to look at your dependencies in your package.json file and install all of those. npm install with a package name will install all the dependencies. I mean, not all, that specific package alone. npm uninstall will remove the package from your dependency. And then we saw the scripts uh, also in the package.json, right? So in that, two of them were pretty straightforward. npm start, npm test, that we can write and run a specific script in our command line. And then when we are writing additional scripts, right? Suppose say development or start specifically to a specific server alone. Then that time you have to put npm run script name. We'll see this also in a while. Okay. Then we have flags. This suppose say I'm going to install a package that's going to be used by my user, and when I deploy it somewhere, it should be there. We directly put npm install package name. But suppose say we are using it only in our development environment. Suppose famously, like I guess testing packages, while testing your APIs in the code level, we use probably something like Jest or Chai, those type of libraries. We want to mark them as development dependencies. They are not relevant to production level. So that time we have something called flags, and this specific flag dash capital D installs it as a development dependency. That also we'll see in a while. Okay. We have something called legacy peer devs also. This usually happens when some of your packages still depend on older versions of other packages. This you'll not encounter right now. This is usually happens in really old code bases, or when you're installing a dependency that hasn't been maintained for a while. Okay, right now we won't run into any of those issues because we are going to use projects like Express, NodeMon that are pretty maintained. All right. Okay. So yeah, we ended up talking about modules and packages in the last session. I guess that was the last topic we discussed. Uh, yeah. So uh, we have something called native node modules that come when you install node by itself. It's like how, the example we used last time, right? When you buy a new phone, it has some default apps like the gallery, phone, the keypad, all those are defaulted. Similarly, we have like modules that come default with Node.js. So here are some of the popular ones: file system, OS, process, path, events. I'll give you a small example also now. Okay, so these are modules provided by Node. You can also create your own modules. Okay, so let's take an example. I have code here running. Okay, let's run the first command, npm init. Okay. It will give me those same things. I'll just put enter, 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 all same. Maybe if you want, you can enter your name also. Totally up to you. Okay, so it'll give you a prompt whether this is okay or not, and just simply put yes.
Long name. Hello.
Oh yeah,
Oh, I guess I'm not audible.
you are audible. Wait, who's speaking?
Oh, oh, sorry.
Wait, who's speaking?
Ishan, Ishan.
Oh, okay, okay, good, good. Wait, did I do something wrong?
No, no, not at all. I was
Oh,
just saying, naam lamba hai.
okay, this is wrong.
It's, it,
Feel embarrassing. Okay, ignore that part. Yeah. Okay, so you created the package.json with the npm init command. All right. And let's try creating our own module. Uh, we know the index.js is the main file, right? And to run it, you just put node index.js. Okay. So that's the problem. Okay. Node index.js, a console logging hello. Okay. So now suppose say how do you create your own modules first before we get into the native node modules. Suppose say I want to create my I don't know custom math library. Though we have a default one, just for understanding sake, we'll do this. Okay. So you'll have function add two numbers which takes an a and b and returns a plus b. I know this is really useless, but just understand it for example. Subtract two numbers. Okay, return it a minus b. Okay, something like this. So I have these two functions here. A module is nothing but a set of functions, right? So I have two set of functions here, add and subtract two numbers. And suppose say I want to use them in my index.js. You can just simply come to your math.js again and just put module dot exports, open an object, okay, and inside this just pass the two functions, okay. Okay, so what this basically does is it takes these two, wraps these two in a common object, and I'm going to export the math.js as a module that I can access from my other files as well. So it's just a simple require statement that you can put like you assign a module to a variable, like how you put name equals a string or something. Same way you can put, suppose say my math live something like this, and then just put require, and then the path to that module. Okay, so it's in the same path, right? Just uh, dot slash math, and then say I want to add two numbers. Okay, let's just put console sum equals my math lib dot add two numbers. You see, it gave me the two functions by default because it knows that these two functions are exported from the math module and I can access it in my other files as well. Okay, so let's just see, add two numbers, I don't know, 10, 20, and then suppose say I want to find the difference between two numbers, just subtract two numbers, okay? So maybe 55, 23, okay? Let's just console log it. Some and difference. And let's run and see it, okay? No index of this. There. I mean, yeah, it's working. See, sum of 10, 20 is 30, difference between 55, 23 is 32. Yeah. I mean, let's not go with the test cases. What if one number is greater than other in the subtract one? Just for now, you see it. This is basically how you can create your own modules. And I mean, you could say, why not just write it in the same file? It's a pretty small code, doesn't really make much of a difference. But in a large code bases, imagine the number of functions like this, number of modules that you don't have, but you put in a single file. It will probably go to 5,000, 10,000 lines of code, and that's not really good when it comes to working as a team or trying to debug your code. It's really tough. But when you work as in separate modules, you're basically code splitting over here, making it more clean and readable. All right. Okay, let's ignore this. And let's see some of the native node modules. So first one we discussed was called FS. FS basically stands for file system. And this module allows you to interact with your files, like your text files, maybe even CSV, Excel files, depends on how you want to use it. Okay. So you can read files, you can manipulate them, you can create new files, you can even delete files, or I guess rename also is one of them that you can use. Okay. So just an example, let's start with a normal text file, I guess that should work. Yeah, let's create a text file. Simple hello.txt with a hello world, something like this. Okay. Yeah. So let's go back here, index. And I mentioned, right, you just use the require statement to import modules. So now how do I know where the FS module is? I told you it's called native node module. So it's available by default in your node environment. So just put const fs equal to require fs. Okay. Just like that. And yeah, okay, ignore that. Then I want to read my hello.txt file, right? So fs has various methods: read file, write file, append file. All these are various methods that I can use provided by the fs module. So for now, we'll just go with a simple read file. Okay, read file. Let's go with this one. So the first parameters is basically the path to the file. I know it's in the same directory, so I can just put hello.txt. Okay. Then the second thing is called a callback function.
Someone said PHP. Oh, TXT, sorry.
Yeah, txt. The second parameter for the read file is basically a callback function. Okay, callback function is basically a function calling another function. I guess we saw this in our beginning sections. Okay, so here it's a function that takes in two arguments, the error and the data. So if error, we see console.log the error and just exit the function. If there is no error, then this console log the data. Okay, so let's just run and see this. If you already have a main pointing to the same file, you can just put node dot. Okay. You see how we are getting this one over here. It's basically a stream of data that needs to be converted into a readable format. Okay. And I forgot how I actually do this. Let me do it quickly. PHP file.
Oh no, did you console log the data?
Yeah, I did.
Console log the data. buffer को convert कैसे करना
Uh, right.
I forgot to decide.
There, simple. You need to convert the buffer to a readable to
Okay,
string
fair,
format.
fair,
Yeah.
yeah.
I mean, sometimes it's just right in front of us.
हाँ हो जाता है.
Yeah. Yeah, so this is, just a simple application read file. It does not have to be just your TXT files. It can be a HTML file. It can be a CSV file. They are most useful when you're coming to creating servers. You'll want to read a HTML file and then return that back as a response to a request. Okay, we'll do that also. So this is just one of it, right? Okay, then I don't know. Should we try appending something? Hello world. Maybe just we'll try appending something in there. Okay. So before that, you see how I have to keep putting no dot for every change that we make. This gets kind of irritating, right? What if there was a way to restart the node server without you having to do this over and over again, just by saving the file? So we do have something to help with that. It's called
Package.json. Oh, node more.
node mod. Yeah.
Ah, ah.
Yeah. So this what it does is it restarts your node process for every change that you make. Okay. So you just come back to your command prompt and just type in npm i dash t node mod. You see here I'm using a flag, something I put. Usually we don't see this, right? It's not something we've seen so far. We put npm I and the name of the package, but you see I'm putting a dash capital D, which basically means this is a development dependency, because I'm using this for Wali when I'm going to work, not when it's actually going to be used by the user or something. So let's go back to a package.json. You will see dev dependencies. Previous time we saw dependencies, under that we saw all the packages, right?
Okay,
So today,
so the dev dependencies will be ignored in production, right?
yeah, it'll be ignored in production. Just
Right.
quickly speaking,
That is
build time.
yeah. Fair, fair, fair.
Yeah. So now how do I use this, right? Come to your scripts and let's just put something called dev and just put node mod index.js. Okay, save this. And now the two default scripts that you don't have to put run are start and test. But for other scripts that you make, you have to put npm run and then the name of the script. Okay. So when you put run, it's going into the file and then it's seeing what's the script. The script is nodemon index.js, and then it's using that to run the server. I mean, check for any changes and then run the server. So right now there's no changes. When I make one, it will come. Okay. So you see, you know what? Let me just come back here. Hello world. Okay. It won't actually read for text files. It's only looking for changes in JavaScript files right now. But you can just put something called rs and it will restart the server. Okay, so now you can see it's brought those changes from the txt file as well. All right. So let's try. Yeah, I mean, the node. This is pretty cool actually. RS
Yeah,
node.
it is, yeah.
Let's try adding data to the file. So we just saw the append method, right? We saw two things, write and append. Append, basically means adding towards the end. Write is basically the overwrite the whole data that was already there. So for now, we don't want to overwrite. We'll just, append some data. So fs dot append file, you see there's a method available. And as usual, it first takes what file you want to append to. It actually shows in your VS Code as well, the path to the file, the data that you want to append. It can basically be a string or a buffer sort of data, and then a callback function that will tell whether it was a, whether there was an error updating the data or not. I mean, it's given here, right? So I like VS Code for this here. That's right. Okay, so let's see. Hello.txt data. I'm doing great, something like that. Okay, and then the callback function that takes in the error. Okay, if maybe error console dot log error like that. So I saved it. Okay, I shouldn't have saved it that quickly. Let's just go back to the code. Oh, okay, it came down. Oh yeah, it came to a new line 2 3 times. I mean, not a new line in the same line because we didn't specify it to go to a new line. Let's just do that. You can use escape characters --n. Okay. So what I'll do now is I don't want to keep it here. This is go into the inbuilt terminal. I want to see the changes right here. Okay, so I have it running here. Now I'll save this file. So it will restart the server, right? So it's going to import fs. Then it's going to read the file and console the data. It's done that right now in the first run. Okay. Then when I save this file, this is actually a new change, right? So it will read update the data and then show it again. I guess this would be better in the dump. So we can see it actually happening. Okay, so I'll save it there. You see now it's actually there in a new line instead of coming in the same line for that. I'll just delete this save. This, I'll comment this out, save it, and we'll see only these two over there. There's something to check. Oh, okay. Yeah. So, okay. Ignore this. Let's go. All right. All right. So you see hello world and how are you? That's exactly the content of hello.txt. But then when I run this code, it's basically appending some new data to the txt file and then consoling it again, right? So I'll save this and you can see now it's consoling these three things and even the hello.txt file is actually here right now. Okay, so like this, we have many methods that you can work with in FS. You can write, you can create new files, you can check if folders or files actually exist, right? I'll just put in a separate file fs.js. So later we can use it, okay? Yeah, the next one was called OS. I mean, OS basically gets the information about your current operating system. So it's, again, you just put a simple require statement for the OS, so const OS equals require OS. And like the things that what can you actually see in your operating system, what platform it is, how many CPUs does it have, what architecture is it using. All these are just some examples uh, to get data of what your operating system is actually on. This is mainly used for when you're deploying your backend and you want to get the information of the deployed system, because when you're deploying, it's not going to be running on your laptop. It'll be on someone else, some other CPU out there. You need to know the exact specification so you can make modifications to how your code actually runs. So let's see, maybe what do we want to get? The platform, okay. It's a method. Yeah, so it's a Windows 32-bit system. Okay, that's a pretty old one. You can get the architecture. Okay. There's also a lot more, I guess. You can get the memory, I guess. Total memory, I guess that was total memory. Yeah, it gets it in, I guess, the number of bytes for each. So this is a really large one. Okay, let's not try to count that. Okay, so OS is one of your native node modules, all right? Then obviously there is others too. There's a process that will give you data on the current runtime, path to combine your paths. Basically, you know how I put /hello.txt, but then for large folder structures, you can actually use this library to make it easier to get the right path to a file. Then you have something called events. This is like the core uh, module of Node.js. Everything that you do on your computer or any sort of task is actually an event. It's either something that you receive or something that you trigger for others to receive as well. So I'll just show you quickly, even like this. Yeah, because this is better. Yeah, this is a better one. So you import the events module and you create a new event emitter. So that event emitter actually takes on two, it has two methods, on and emit. So on takes in the type of event that you're trying to receive, and emit actually, triggers that event. So I have an event, I mean a function that basically console logs, I hear a scream. Uh, and then when someone's actually screaming, that is on screen, you actually call that function, you invoke that function. And when you actually want it to happen, you use the .emit method. So this is very basic example, but in an actual backend application, these events are really useful. Like maybe when I don't know, maybe a memory related event, or suppose say you're getting a lot of requests to a backend that time switch to a load balancer sort of thing. So it's really useful to have this module as well. Okay, so for now we'll not be using it, but it's good to know like this is one of many modules. If you want to see uh, let's see, go to the documentation. Yeah, so let's go to the current LTS. Okay. So these are all the native node modules that are present. Okay, you you saw the FS just now, should be um, somewhere here. I guess file system. Yeah. So the full documentation is here on how to use it. Okay. So what we saw is just one of many modules that Node actually has. You have the V8 also that you can directly access the JavaScript engine, which is some pretty cool stuff as well. You have the crypto library that helps encrypt and decrypt data. You have the HTTP library also that we'll see in a while to create servers. And something really cool is we have this thing called C++ add-on. So you actually can customize the way your JavaScript engine works with some C++ code that you can run through Node.js. Okay, so it is pretty cool stuff. There's lots of things that to explore with this, but we'll actually look at the essential ones in the coming sessions. All right. So any doubts so far? I mean, that was at least half of the session, but the other half is just a pretty straightforward one. Any doubts so far? Just drop in the chat box or you can unmute. Cool. Okay. Let's move on. Okay. So before we actually get to creating a server, just a second. Yeah. Before we actually create a server, just need to understand this very simple cycle called a request response cycle. So you as a user, when you suppose you want to go to Instagram, you put instagram.com, that goes to a server, and the server returns you the Instagram feed, right? So basically what you're doing is when you're typing the URL instagram.com, you're basically putting a request to a server And that goes to the server telling like, hey, this user Kunal Keshan wants to get his profile or get his feed. So it sees the data in the request. Like currently you are logged in and to get data relevant to you. So to do that, it goes to the second phase called the process or the business logic, where it says, hey, the data received is from Kunal, like he wants to get his feed. So accordingly get the feed for the people he follows and the uh, automated feed, right? Like recommended feed for you as well. So it will get all of that together, compile it, will process it together, and then it will respond back to me in form of a HTML page, right? So it responds with the logic that I requested for initially. Suppose say I go Instagram.com / Think Digital, right? So it's saying, hey, this guy wants to access the profile for Think Digital. Get the date, the feed for that profile alone, like their post alone, and respond with their post to to that same request. So this cycle happens over and over again. Every request, every interaction that you do with any website goes through this cycle. When it comes to uh, when a backend is involved over here, okay, a request response cycle. So it's pretty straightforward. Anything and everything that you work with will undergo through the same thing, and all the logic that you write happens in middle of these two. Okay. So let's get started, creating a basic server using the Node.js HTTP module. So HTTP module is a native Node module, which works on the hypertext transfer protocol to send and receive data on specific ports and host, okay? Host here, nothing means your IP address. When you're working in local, your host will always point your internal device. That is 127.0.0.1. Okay, so this is your internal device IP address. If I try to type this in my laptop, it will only point to my laptop's IP, I mean laptop's local IP address, that is 127.0.0.1. And then you see you put a colon, it can be anything, 3000, 5000, something like this. That's basically a port number. So you have many ports in your system that can run specific programs or processes. Okay. Basically, I don't have to limit myself to just one host and one program. Having a port allows me to run many programs within one single device. That's how a normal system works, right? You can do many things with a single system. Same way, ports allow you to run multiple programs or processes in the same device. Okay, coming back to it. So it's just a simple three-step flow. You import the module, create a server object, you pass in the function that will handle all these requests, the request response cycle that we just saw, right? It will handle all these requests and then accordingly give a response based on the request. And then we just have to start the server and start listening for requests. Okay, so before we actually get in, I'll just get in a small theory part of how it actually works. But you need to know, like, it is not necessary for you to know how this actually works in the back. This is actually some really deep networking stuff involving your TCP stack and all that. You don't need to know it. It's not compulsory, but it's really just a additional thing that you can explore if you're interested in networking. Other than that, it's not really necessary for you to know it. But when it comes to like actual backend jobs or something, they will expect you to understand how how starting a server actually works. Okay, so that's when in backend I know it's a bit more strict. You have to know how the actual code works, what's the logic behind the code, uh, bit of networking concepts, DBMS, OS, all these come into play when it comes to backend interviews. Okay. All right, so let's just try creating a server with the HTTP module. It's just a simple const HTTP equals require HTTP. And the first one was to create a HTTP server object. So const server equal to HTTP dot create server. Okay, and it takes in a request listener. Okay, request listener basically is nothing but your request response cycle. It listens for any request that the user put. sorry. Yeah, and processes that request and sends a response. Two keywords here, request, response. Okay, so I'll suppose I'll have my function request handler that takes in two things, request, response, like this. And what I can do is I can just take this function and pass it over here. Okay, so two keywords, request and response. I mean, you can put the full word also, it's not mandatory you have to shorten it, but it's become a convention to write request as REQ, response as RES. Okay, so you can either write it separately or you can very well put it over here as well. Okay, and by default, it will always go to the / part, but we'll get to that in a while. So now we have two parts covered, the server object and the request handler. Basically, that handles your request response cycle. And the third part was listening for the request, right? We just put server.listen, and listen takes in two parameters. The port we just discussed, right? The port, where will the server actually listen for all the changes? And the last part is basically your callback function to, like, if the server is running successfully, then call this function. So suppose I wanted to run on port 5000 and okay, I'll just put console so port 5000. Okay, I haven't saved it yet, but we'll just go is uh, let's save it. There, you see, running on port 5000. But now if I actually try to access it, you can put 127.0.1.5000. It will not give me anything actually. Even if I go put localhost 5000, it won't run because I haven't specified any logic for what will happen when the user actually asks for this puts a request to my server. There's no logic, it's empty, right? So it's going to return nothing. It's just stuck over there because it's waiting and waiting and waiting, but nothing is going to come back eventually. Localhost basically it's a alias name for your 127.0.0.1 IP address. Like how we have domain names for actual IP addresses. Same way, it's localhost, you can consider it as a domain name for your local system's IP address. Okay, so let's do this. Let's actually try and write and see how to actually create that request response cycle. So suppose say for my just a slash request, that is localhost 5000 with a / basically nothing after it. For this request, I can just put response dot write, and I can just put okay, and then end the response. Okay, I'll save it. I'll go here. There you see. So it returned me back the text file. I'll reload this. For this 5000, it gave me hello there. Suppose let's console log it also. Request me. Then this is the logic. Then console.log response sent. Let's come here with the request. Go back. See, request made. Okay, I was running it 2 times. That's right. So request made. We process the logic. It sent hello there to back to the user. Specifically responded back hello there, and then we are ending the process. We need to end the process. I'll explain why in a minute. The theory part. And then I'm just consoling response end. Okay, so now how does this actually work? What is actually happening when I put server.listen? Why should I end this the response? Okay, so coming back to the schedule, yeah, so how does it actually work, right? So you can consider it a 6-step process. So when you're actually putting server.listen, you're creating a socket connection. So a socket is nothing but a stream of connection between your server and the browser or any other client entity that's putting a request. Okay. And what it's doing is that socket is being binded to your host, that is basically my IP address and the port. So this one and this one is getting binded to my socket. So it's like telling, hey, this stream of data is taking place over here. Okay. So it's basically like the where of your code. It's happening over here. Then finally, this socket, it listens for incoming requests on the TCP stack. TCP is basically your transport connection layer. So we don't need to get much detail in that. Even I'm not fully sure how to explain it in depth, but just know that it listens for any changes or any request that comes to this specific host and port, and then it notifies your socket that, hey, somebody's trying to request, will you accept it or not? So by default, if everything's okay, by default it will accept the request. Then the specific read and write operations will come from the request object. Once that is done, I'll respond, and then I need to close my connections. So that's what the sixth step is. So once it's done, close the connection and create a new one in case there's another request. Okay. So you don't need to keep the connection open all the time. I guess you can set it to keep it open for maybe maximum 5 seconds. That is basically because if a connection is already open, transmitting data between them becomes easier. But keeping it open all the time is really heavy on both on your browser and on the server. Specifically on the server, because imagine there is tens of thousands, or Instagram has millions of users at the same time, right? If the server keeps the connection open all the time for all the users, it's going to be really heavy and it's going to slow down the request response for many users. So you need to explicitly close the connection, basically end the stream of data, and let the user know that, hey, this is the data, there's nothing else to be communicated anymore. Okay. Just for learning sake, let's do index.html. Index file, okay, and I'll just create a hello.html. Okay. H1 and my hello. This stuff. Yeah, hello dot, just put hello file. Okay. So suppose say for my /path, I want to send the index.html file, and for my uh, /hello path, I want to send the hello.html. So what I have to do is I'll have the request object here. So request is what the user actually put. So you can do a request dot URL dot path name, I guess that. Oh wait, you need to import another library called URL. Okay, and just put const URL equals URL, passing the request dot URL. Been a while since I used this. Yeah, and then dot pathing. Here, request. I was just putting this. Yep, my bad, my bad. It's the parse method. Okay, good. So we see there's another module called URL, and URL, it has a parse method that can take in my request URL. So imagine I have localhost 5000 or maybe like hello, and it can go many paths deep, right? 1,2/3, something like that. It can keep going deep. It can have some query parameters like maybe a equals 10 and b equals 4, something like this. Let's just try putting this itself. Okay. Instead of this, I will just put it in there. See, so it gives you various methods. So what protocol is it using? What's the host? What's the port? What's the path name of the request? Is there any search query like that? So it gives you the whole details of what the actual user request is. I told, right, when putting a request, you need to see what data is actually there. So for now, I'm not looking for this one. I want what the user actually requests from. Excuse me. Yeah, save this. So I'm getting like my path name / right? If I put uh, hello, you can see I'm getting / hello. So what I can do is I can just do if URL dot path name is equal to / else if URL dot path name is equal to / hello. Okay. So we'll use the FS file over here again because we want to write back our HTML file. So I'll import FS. See, like all modules in Node.js actually do play a role. Okay. So I want to suppose say read I actually need to read the content as a blob and then respond that back so that my uh, browser can know what type of file it is as well. Okay. So just simple read file. Taken the path to the files. In this case, it's the index.html, and then callback function, store and data. Assuming no error for now, so response dot write data, and as I mentioned, always end the response. Okay, so this is one. In my other case, I want to return for the hello dot HTML, right? For the hello part. Okay, so it is working. So here, if I just go to my index file, it's returning, right? Pretty cool stuff. Okay. So this is how you actually write just using the HTTP module. Now that there comes another layer of complexity where you don't have to differentiate only by the path name, but by the method also. So you have to, so let me just show it here, console.log request.method. We are considering that as well. So you can see I'm getting a get method over here. All right. Now suppose say I'll come to my postman. Okay. I'll just add a new request directly. Without permission. Okay. And it was in my localhost 5000. Yeah. So basically, how you work is it's not necessary to create a collection. You can directly add a request as well. If I'm not wrong. Okay, in a collection you need a request. My bad. Okay, so create any collection, name it anything, and inside a collection for now, just you'll get an option to uh, add request or add folder. Click on add request, and over here you'll get a tab to enter the URL and various other things that you can add to it as well. All right, this we'll see one by one. But for now, as simple by default, let it be get request, and then just put a request to that URL and click on send. See, I'm getting the same HTML file. I can preview it as well. Suppose I want to do the hello. I can send that and I'm getting the hello file as well. For now, this is simple get request. In my server also, if I see, it's all get request at the moment. But suppose say I wanted to put a post request instead. I can just come here to my postman tool and change the various options I have here. I'll change to post, I'll put on send. I'll get the same file because I'm not differentiating by the method. I'm differentiating only by the path. But you can see now it's a post method, right? So we have this various types of methods called HTTP methods: get, post, put, patch, delete, head options. So don't worry about the last two. So these methods, they specify what type of request the user is making. Get request basically means just to fetch data without uh, much, without changing anything, just get me the same data. Okay. Then post request basically means you want to create something new. So in that case, you'll put a post request. Okay. Then put and patch basically means to update an already existing data and delete, as the name suggests, to delete a specific data. So basically, you get something called CRUD operations, CRUD, which stands for create, read, update, delete, that you can do using these various methods and the various path names that you will assign over here as well. So we this actually comes under something called RESTful convention. It's called the representational state transfer, which we'll not see today. We'll see in the next session. But just know that when you're building APIs, it's a good practice to either follow this specific architecture, or there are others as well, but this is the most used. Okay. All right. So this was one way. We have this one more way of creating it. Okay. Using a library called Express. So how do I use it? Okay, just simple. You install Express first. So npmi Express. Okay, go to my package JSON. Yeah, dependency Express. It's here. Come back to my index. So for now, I'm not going to use any of this. What I'll do is just const Express equals require Express. Okay. This you see how I'm importing Express same way as the native node modules, but this does not mean Express is part of your native node module. It's just that node, it creates a path to where it's actually installed, and we learned that all these are installed inside the node modules, right? So now it's the same way. I create my server object, so const app equals Express. Okay, and then I start my server using the listen method, app.listen, the port, and then a callback function. So we're running. Okay, I'll npm run dev, and it should work there. So we're running. Okay. So now instead of me differentiating between each path and each method, which is really gruesome and hectic with the HTTP module, what Express allows me to do is just write app.get, so I can use the HTTP verb directly, and that takes in the path uh, to that get request. So just slash, and then I can just put the function directly. So each request has its own request handler, request response, and then response dot send hi, something like that. Okay, we go hi. That's it. Pretty cool stuff. So you can have many uh, paths, and each path having a unique method. I can even put app.post /. So these two are completely different from each other, just that they have different methods. Okay. Uh, I just want to show, so this is like, so big, whereas it got so small with Express, right? Uh, so I'll get into Express again from scratch in the next one, but just wanted to give you an overview. All right. So for the TD guys, I actually have a small task for you. I know some of what we haven't covered, but I want you to try it out by yourself. Okay, so basically just create a node project, have a server.js or index.js file, set up a server using Express, create a GET request that returns a HTML file with a form with the name and age. And when they submit the form, it will create a post request to another submit route, and it will take in the name and age and return that back to the user in a new formatted way. Okay, so you can use either the browser or Postman to test it out. Any port you can assign 3000, 5000, that's up to you. And yeah, just try this out. Try to finish it by coming Monday before our next session. All right. Okay, I have to cut it short because I'm having the stand-up meet. But just let me know if you have any doubts. We can clear it in a later meet also. Okay. I'll share the code and all this properly. I'll fix it along with this escalator file. Okay. So hope you guys like the session. Let me know about it later. Right?